This lecture segment covers the use of the preprocessor #IfDef directive and its relatives. This directive is often used in large code bases to manage compilation for different machines, to prevent multiple file inclusion, and for other purposes. As a prerequisite to this segment, you must understand what the C preprocessor is, as opposed to the compiler, when the preprocessor runs, and how this impacts the source code the compiler actually sees. Review early phases of the lunar lander example, if needed. Let's look first at the ifdefs1.c example code, which begins with 3 preprocessor directives, a pound include, and then 2 pound defines. Now, as you know from prior review, first, these will be done by the preprocessor. Second, the first directive will merge the entire content of standard.io.h into your source, and the second will replace all occurrences of dim with 10. Third, the code resulting from these preprocessor directives is what the compiler sees and compiles. It does not see nor compile your original source directly. And then 4, you can see the results of this preprocessor work via the -e compiler flag. What may be new to you is the second pound define, which has no value for the init string. This pound define will replace all instances of init with nothing at all, but that's not its real purpose. As we'll see shortly, there are preprocessor directives that check whether a given pound define has been made at all, regardless of the value to be substituted. And to support these directives, one often writes what we'll call flag defines. Those are pound defines that declare a define string with no substitution value. The mere existence of the flag define is sufficient. Its value doesn't matter. So, what preprocessor directive uses flag defines? Check out the ifdefs down here on line 10 and line 13, and their partner ndefs that match them here on 12 and on 16, respectively. These look a little like preprocessor if statements, and in fact that's exactly what they are. An ifdef takes one string argument, like debug. If a pound define for this string, either a flag define or a normal one, has been encountered already, then the ifdef is true. Otherwise it's false. A pound define later in the file doesn't count. The pound define must already have been executed by the preprocessor. Now, if the ifdef is true, then the code between it and the matching ndef is seen by the compiler. It appears in the preprocessor output. But if the ifdef is false, then that code is omitted entirely, and the compiler never even sees it. This ability to selectively include or disclude segments of code from the compilation is called conditional compilation. So in the example file, the compiler will never see the code inside the ifdef debug, the line 11 code, because there is no pound define debug. But it will see lines 14 through 15 by virtue of the flag define for init on line 4. Let's check this out by running a -e compilation. So we'll do a -e on ifdefs1.c here. And as you can see, we first get a really very large amount of output and unreadable. That's standard.io.h being pound included, plus any header files it might in turn include, by the way. Do recall that includes are recursive. If an included header has pound includes within it, the preprocessor includes those as well. That'll be important in our next segment, in fact. Now, in the code we wrote, which finally appears at the bottom, the processor, or the preprocessor, substituted dim with 10, as you can see right there. And per the conditional compilation rules just discussed, the preprocessor drops line 11 here entirely, but keeps lines 14 through 15, the for loop. Now here's question number 1 for you. There are quite a few preprocessor directives related to conditional compilation. As an external research task, look up some pages on preprocessor directives. That way you'll have a resource you can go to when you want to look them up later. And tell me how you would arrange for one of two alternate versions of a block of code to be compiled based on, say, a flag defined called choice. So I want one or the other, depending on whether choice is defined or not. And coming back from a suitable pause there, what you're looking for here is a pound else. You can add an else branch to the ifdef. Ifdef, say, choice, put block 1 down, and then pound else, and block 2, and then finally the end if. You may also have a solution, by the way, using ifDef for the alternate block if you did your research in a different direction, but the pound else is preferred in this case. We'll be looking at if and def in a little bit. Now, pound ifdef is actually an old preprocessor directive from C's origins in 1970. The more modern, originated in 1989, directive is pound if, which allows a more powerful logical expression as a conditional compilation test. Now, pound ifdef still gets a lot of use, so you really need to know both. But here in the transcript, and we'll drop it up in the slide here as well, is how the line 10 ifdef would look using pound if instead. The pound if directive allows full use of C-style Boolean operations and uses defined like a Boolean function to test flag defines. Now, question 2. Look up pound if and the related Booleans that it allows and show how you would conditionally compile a block of code only if flag define v5 was set and flag define Unix was not set. Coming back from a pause where you looked that up, what you would write is pound if defined v5 and double ampersand not defined Unix. Just about like that. As your research should have found, pound if permits general Boolean expressions using relational and equality operators and the Boolean operators bang, double and double or. Importantly, though, these work only on constant data, including constants provided by pound-defined substitutions. So, for example, in the transcript here, we could have pound-defined version as 2 and pound-defined word size as 32, and then do a pound if version greater than or equal to 2 and word size equal to 32, and put in there a code that would apply apparently for versions 2 or later with a 32-bit word size. If you do comparisons on non-defined constants, by the way, the result is always automatically false. Now, question 3. What happens if I use pound if with C variables as opposed to preprocessor defines, like this? Just copying from the notes there, the transcript. Try this out. Actually compile it, and then explain the result. So there's your third in-lecture question. And coming back from trying that out and explaining the result, the pound if fails. So version 2 does not get included in the code. And the reason is that version is not a defined constant. And the test is therefore false. The preprocessor has no knowledge of C. It works only with its directives and considers all other text to be simply a target for inclusion or disclusion, defined substitution, and so forth. So it doesn't know that version is a C variable with value 2. Since there's no pound-defined version 2, the term version is simply undefined to the preprocessor. Indeed, people sometimes use the C preprocessor to do defined substitution and conditional inclusion or disclusion of content and so forth on text documents or on source code for other languages. It's really a separate tool from the C compiler. Now, a common use of conditional compilation is to include or disclude debugging code based on a flag define, such as debug. By including a pound-defined debug line, we can get the line 11 printf included in the source, for instance. Now, we could do this by inserting a pound-defined debug at the top of every source file where we wanted debug code to be included, but that'd be pretty tedious, especially if we often wanted to shift between including debugging code and then omitting it on different builds. Instead, all C compilers allow you to set a flag define via compiler command line option -d, which is followed without space by the define you want. So, for instance, gcc-d debug, and then source files, does a compilation as if you had a #define debug in every source file. And as you can see from the notes, doing this in combination with the -e option shows that line 11 printf in the preprocessor output down here. So that'd be the command, line 34. This is just a added comment, really. And the result down here does include the printf. Or if you want to see it in live form, like this. And there we do have the printf. Now, let's wrap this up with a little bit of a discussion of the proper use of conditional compilation. Conditional compilation is a tool to be used sparingly. Common uses include the debug example just discussed, so that you can have alternate debug and non-debug versions. Alternate source code for different architectures, so different source versions for big and little endian processors, perhaps, or for 32-bit and 64-bit processors. But an excess of flag defines for conditional compilation can make a project unmanageably complex. Each different flag define combination results in different conditional compilations and thus, in effect, different versions of the codebase. So here's question 4 for you. If I have 3 different flag defines, each causing conditional compilation effects, how many different possible versions of the code can be obtained by varying the setting of the 3 flag defines? Coming back from a pause there. Well, 8 versions. For instance, if the flag defines are debug, little endian, and bit 64, then we can set them to obtain a non-debug big endian 64-bit version, and a non-debug big endian 32-bit version, and a non-debug little endian 64-bit version, and so on. The reason I'm just iterating that is that it makes it clear that there are a lot of different versions, even from 3 flag defines. And so, question 5, now make it 10 different conditional compilation flag defines. How many versions are there now? Coming back from a pause, this is really more a combinatorial math question than it is a compiler question. And the answer is that the number of versions is 2 to the nth, where n is the number of flag defines controlling the conditional compilation. Each new flag define doubles the number of possibilities. With 10, you get 1,024 versions. Now, you don't even want to think about setting up test cases for all those versions. So keep the number of conditional compilation flag defines to a minimum.